You ever wonder how a simple idea transforms into a powerful AI that can predict diseases or spot tiny flaws in a system? Well, it's not magic, it's a process, a journey, really. And today, we're going to walk through the builder's blueprint for that journey, step by step.
Yeah, it really all comes down to this one big question. How do you teach a machine to look at, say, a bunch of complex brainwaves and spot a pattern that might signal a serious medical issue? The answer is having a solid, structured plan.
And that plan, that's the neural network workflow. The best way to think about it is like the architectural blueprint for a massive skyscraper. You can't just start throwing up steel beams, right? You have to follow the plan meticulously. Because if you skip a single step, the whole thing could come tumbling down. So here's our roadmap for this journey. We're going to cover these 5 essential stages. We'll start with the blueprint itself, framing the problem. Then we'll gather our materials by prepping the data, pick our tools by choosing a model, stress test the whole thing through training and testing, and finally, cut the ribbon and deploy it. All right, first stop, framing the problem. This is kind of the measure twice, cut once part of the whole deal. Before you write a single line of code, before you even look at data, you have to know exactly what you're building and why. You got to define your destination before you start the trip. So what does that mean, problem framing? Well, it's the part where you get super specific. What is our exact goal? What does success actually look like? How are we going to measure it? If you don't nail this down, you're basically just wandering around in the dark. This is what separates a cool tech demo from an AI that actually solves a real problem. Okay, let's make this real. Take epilepsy detection. The goal wasn't just build an AI. No, the goal was early detection, super specific. They knew exactly what data they needed, EEG signals, clinical info, and that let them set precise, measurable targets for their model. That sharp focus right from the get-go, that's everything. Okay, so we've got our blueprints. Now what? Well, now we need our building materials. And that brings us to step 2, preparing the data. If the problem is your blueprint, then data is your steel, your concrete, your glass. And you can't build a strong skyscraper with rusty, flawed materials. The fancy term for this is data preconditioning, but really, it's a massive cleanup job. Real-world data is messy. It's chaotic, it's got missing pieces. This step is all about whipping it into shape, cleaning it, and formatting it in a way the neural network can actually understand. It is absolutely non-negotiable. Now, one of the biggest traps you can fall into here is imbalanced data. Imagine you're training a model to spot a rare disease. If 99% of your data is from healthy patients, the model can learn a lazy trick. Just guess healthy every single time. It'll be 99% accurate, but totally useless, right? That's a biased model. You need balanced data, where all the possibilities are represented fairly, so the model is forced to actually learn. So how do we fix that? How do we balance the scales? Well, one really cool technique is oversampling. A popular method is called SMOTE. It's a bit of a mouthful, synthetic minority oversampling technique, but what it does is genius. It cleverly creates new, synthetic examples of the rare thing you're looking for to even things out. It's used a lot in cybersecurity, for example, to help models get better at spotting those rare 1 in a million network attacks that could otherwise slip right by. All right, our data is prepped, clean, and balanced. Our raw materials are ready to go. Now it's time for stage 3, choosing your model. This is like a master craftsman opening up their toolbox. And believe me, it's a big toolbox. You can't use a hammer for every job. You need to pick the right tool for this specific task. Let's break it down. If you're working with images, say diagnosing a wound from a photo, your go-to tool is a CNN, a convolutional neural network. If you're dealing with data that comes in a sequence, like text, then you'd grab an LSTM. It's perfect for things like spotting deceptive online reviews. And sometimes, for the really tough, complex problems, you combine different models in a hybrid approach. The big takeaway here is simple. The nature of your data tells you which tool to pick from the box. We have our blueprints, our materials, and our tools. Now for stage 4, where the real action happens, training and testing. I love this subtitle, The Lab and the Gauntlet, because that's exactly what it is. First, you build and teach the model in the nice, safe, controlled environment of the lab. And then you make it run the gauntlet to see if it's truly ready for the real world. So what does this gauntlet look like? Well, you use things like cross-validation to make sure the model performs well no matter how you slice up the data. You might use some really tough methods like leave one out tests where it gets pushed to its limits. And, critically, you stress test it.
You throw weird, unexpected, difficult data at it just to see if it breaks. This is how you build real confidence in what you've built.
And does it work? Oh, yeah. After putting a model through a tough leave one out validation for classifying mental workload from EEG data, researchers hit over 81% recall. Now, that number isn't just a good grade on a test. It's proof. It's proof that the gauntlet worked and the model that came out the other side is genuinely robust and reliable.
And let me be crystal clear about why this is so important. It is easy to make a model that looks amazing in the lab on clean data. But the real world is messy and unpredictable. Without running this gauntlet, that star student from the lab can and often will fail spectacularly out in the wild. This process is your firewall. It prevents dangerous failures.
Which brings us to our final stage, deployment and beyond. This is the moment of truth. The skyscraper is finished, the doors are about to open. The blueprint becomes reality, and our carefully built model is released into the wild to finally do its job.
But going live isn't just flipping a switch. You have to think about all the real-world challenges. Does it need to work in real time, instantly? Can it scale up if millions of people start using it? Can it run on a tiny piece of hardware, like a microcontroller? And maybe the biggest one, you have to constantly monitor it for something called model drift. That's when a model's performance gets worse over time because the world changes. The job is never really done.
A huge part of this final stage is accountability, and that's where model cards come in. Honestly, just think of them as a nutrition label for your AI. It transparently lists all the ingredients, what data it was trained on, its performance metrics, and so importantly, what its known limitations are. This is absolutely key for building trust and making sure AI is used responsibly. So there you have it, the 5-stage journey, all the way from a question to a real-world AI solution. It's a rigorous, detailed process, no question about it. But with this blueprint, with this map, the potential is almost limitless. Which leaves us with one final thought to chew on. Now that we have the map, what incredible new worlds will we choose to model next?